All right, so speaking of activity that's being observed,
Yeah.
there was a specific case, I guess we have a few things to talk about relative to DNS, and this is one particular case where it's not acting, or it didn't act the way it's supposed to, right?
So there's a couple of interesting aspects to this one that the first one will be of interest to all. The second observation that I have is interest to like real down and dirty nerds like myself. But the first part of it is FireEye put out a report about another APT operation. APT is these targeted campaigns by actors who are targeting specific groups, trying to get intellectual property and whatnot, sometimes at the direction of a nation state. And the interesting thing about this is they started to observe a particular type of Trojan called PlugX, which we have some experience doing analysis of as well. And it was connecting to legitimate domains. So it would look like it was connecting to www.adobe.com, www.outlook.com, but when they actually looked at what was going on, the DNS resolution coming back was for an IP that did not belong to either of those two parties.
Right.
They did a little more digging, and what they observed is they were talking, the client machine was talking to Hurricane Electric DNS servers. So this is basically what they discovered is that Hurricane Electric, they're an ISP, they do a lot of IPv6 hosting as well. They have a hosted DNS service where you can register a free account, and then you could put your DNS, what you want to register in there, and then, kind of like a dynamic DNS kind of thing, but even more so, you could specify the domain you want. So the bug was you could specify domains that are already registered out on the internet. And that's what these actors were doing. So first of all, what they would go in is they registered these legitimate domains pointing to their IP addresses, and the Hurricane Electric DNS servers would respond, if you asked them, you would get a incorrect IP address back for that name. So then the next part of that is, well, that's only going to affect people who use Hurricane Electric for their DNS service. And what the PlugX Trojan that actually was implanted on the machine, it would do kind of a DNS changer type of behavior, where it would change the local DNS on the machine to use Hurricane Electric's DNS servers. So now you've got the path complete there. The Trojan looks up the legitimate domain, but gets the rogue IP address back. Now it can connect to whatever it needs to. There's a couple of different targets which are outlined in the article. And if you're in that kind of target set, you might be interested to go look at that. You might also want to take a look at in your enterprise or your corporate network, if you do see devices in your corporate network trying to go out to Hurricane Electric DNS servers. You might, not to say that that's a bad thing, but you might want to go check, what are they looking up there? Is this, a legitimate type of activity going on or not? Because chances are you probably want them talking to your internal corporate DNS servers, not to an external one, or ones that you have some relationship with. So there was a second part of this campaign that was also interesting. So related to the same actor set, they also noticed another Trojan, PlugX Trojan, that would go up to a Google code repository. So they kind of have their own Google code. You can set your own project up and whatnot. And on that page was just a hexadecimal string. And what the Trojan would do is go up there, it would look at that string, decode it to get an IP address. And that's where it would actually connect to do the actual command and control from that point on. The interesting thing to me about this is we know some things about PlugX. It's got modules in it to do command and control with HTTP, which you see a lot. That's what the first one that we were talking about did. It also has like a TCP socket that it uses as another encrypted kind of communication. And then it also has a UDP module to do it over UDP as well as ICMP. This one's using UDP to connect, which to me is kind of interesting because it's very rare that you see that, or at least our experience, we haven't really seen many of these PlugX Trojans using UDP as a protocol for command and control. So a lot of interesting things. The full article is very interesting. I recommend people check it out because it's got all the IP addresses that they've observed. There's many other Google code projects hosted by that same person, whoever that is the one that they found here, and they have different IPs. So there's the same kind of thing going on with different IP addresses, probably for other campaigns or other victim sets and whatnot. Because we tend to see that with these targeted ones, they might use the same Trojan, but then have a different command and control for different target sets, so that kind of distributes it around, and they can keep track of who's who and whatnot.
Right.
So.
All right. Well, I mean, that's
There's
a handful of stuff.
A lot of ground covered on that one,
Right.
but there's a lot of interesting tactics that have been used in this by this particular actor.
Okay, so we have rogue domain names for already registered domains due to a bug in a DNS service,
Right.
and then malware redirecting to use that DNS service so that they can get effectively what would look like a hijack or poisoning of those particular domain names, and then directing through a variety of protocols to be able to go to basically a command and control server and take control of the system.
And PlugX, I should mention, is kind of a remote access Trojan kind of backdoor kind of thing. It allows them to, you know, as though they've got a command shell and other types of facilities out there, so they can really root around any machine and see what they're doing, and then move laterally and stuff like that.
And I presume the protocol diversity in PlugX is to be able to subvert whatever firewall rules in place. Find whatever will let you through, and then use that particular port, whether it be UDP or TCP. Oftentimes, you know, if they're being forced through a proxy, I assume they're going to try to avoid that. And if they're, you know, oftentimes people aren't really paying attention to what's going on in UDP, so it would, particularly outbound UDP.
Right.
And so that's a case where it might give them an opportunity to get out in ways that hadn't really been anticipated.
And their ability to, well, their usage of kind of using legitimate domains in a rogue way could really trip up maybe someone who's not up to speed. So if you're, you know, a security analyst looking at proxy logs and whatnot, you might just say, oh, he's going to Adobe.
Right.
But that might not really be the case in this particular situation. So it can really trip up somebody who maybe isn't looking more deeply and is only looking surface deep at the activity that they're seeing.
Well, and then on the surface, you'd think that, well, why not just simply analyze DNS to see that, you know, domain names are resolving the IP addresses they expect. But, you know, with all the content distribution and the diversity that exists in the hosting, particularly with cloud, and it gives you the opportunity to expand and contract as you need to, it makes it a little bit more of a complex process. I'm not saying you shouldn't do it. In fact, I think it would be a valuable thing for organizations to do. It's just not perhaps as straightforward as you might expect.
Right.
Right. So I guess the sort of the obvious question here, and I'm interested in your opinion on this. John's got a smile because he.
Yeah, I know what this question's going to be.
Would DNSSEC help us?
I don't know. I can't say for certain that it would help. So with this particular type of activity going on here, even if you had DNSSEC in play, it's unlikely that a malware Trojan is going to give a hoot about whether this is legitimately signed, this DNS answer. But you might be able to do something, you know, in your IDSs and whatnot to maybe somehow do something. I don't know if that could be done. And I doubt that Hurricane Electric was doing any kind of DNSSEC signing for these domains that were registered.
Yeah, good point.
You know what I mean?
It was a hypothetical question, so I guess there are a few things that sort of come to mind. First of all, if you're operating an enterprise, you probably want to control what DNS services you're going to.
Yeah.
So most enterprises, large enterprises, are going to be using their own resolvers anyway, and so they wouldn't necessarily get sucked into this problem. That is, if an internal machine ends up with malware that tries to change the DNS servers that it's going to, you wouldn't want to let them out to whatever DNS service that's available. Have them do their resolution through the path, which would force the authoritative chain and not run into this problem. That's presuming the DNS resolvers don't have the same sort of bug or some sort of an issue, of course, but that's we sort of presume that to be the case. I guess and so if that infrastructure is doing, the DNS infrastructure is doing DNSSEC validation, it would potentially help. That is, you wouldn't necessarily get a rogue DNS response through the DNS infrastructure. But as you pointed out, the malware itself, if you're depending on the malware to do that validation, the malware doesn't care. And
if that validation is pushed to the end client, it's, you know, the end client can't be trusted at this point because it's infected. Yeah. So.
And we've seen that with SSL certificates. SSL certificates are often, used by the attackers. Will often have rogue attributes associated with them, lie about who they are, or be expired and presumably stolen from another server or something like that. So I'm inclined to say, and as you pointed out, it's somewhat conjecture because we don't know the full circumstance around this, but I don't think even a robust DNSSEC infrastructure is really going to do much to prevent this sort of thing. But there are certainly controls that can be done in the enterprise or as a part of your DNS services to help at least make it much more difficult to do this sort of thing. Right?
I agree.